It's going on page 97 when we're done. Okay, so DMS is just shorthand for degrees, minutes, seconds. It's just a different way to notate angles in degree mode that are not whole numbers. And it has different applications. Let me fix that real quick. We'll talk about those here in just a minute, but let's see how we do it and what it means, and then we'll talk a little bit about that. It's not something, I didn't ask, we've been asking Mr. Ackerman a lot of things like, are these things that they absolutely have to have for calculus? Because if so, then we make sure we really focus on it. If not, we still introduce it, like there's some things you still need to be exposed to and learn, but we don't necessarily, it's not quite as important. This one I didn't even ask him about it until at lunch, just because he happened to be in here, because it didn't matter to me, because whether you use this in calculus or not, you still need to be exposed to it in general, just as an average citizen, so you know at least it exists, even if you don't know how to convert things, just so that you know what the heck people are talking about. And it does have, from what I gather from this morning, you haven't used it in physics. That doesn't mean that you won't, or that you wouldn't in some other science class, because it very easily could be put into physics. It probably just isn't necessary, so they don't talk about it this way, and it's fine. But it says some angles have decimal degrees. For example, 26.5 degrees. Angles with decimals can be expressed using degrees, minutes, seconds form, in which degrees are subdivided into minutes and seconds. Just like hours are divided into minutes and seconds. But this has nothing to do with time. It's just kind of like a baby goat's called a kid, but it's not like one of my kids, right? It's just a different way to handle it. It has nothing to do with time. It's not even notated like time. It's notated like something else. But we treat it like time as far as conversions are concerned. So at least that makes sense. So 1 degree then, just like if you pretend like that's 1 hour, is 60 minutes. Okay? And just like with time, 1 minute is 60 seconds. And again, just like with time, we could jump from hours to seconds. How many seconds are in an hour? 3,600. And that's how many seconds are in a degree, because you'd multiply those two together and you get 3,600 seconds. Okay? The symbols that you use for the notation, degree symbol is still what a degree symbol always has been. Minutes looks like an apostrophe. Seconds looks like a quote. Okay. What else uses the units as a feet and inches, right? But it'll be very obvious that you're not talking about feet and inches, even though they're notated the same way. It'll be real clear just how things are worded. Plus, it would have to be preceded by a degree sign for it to be an angle measure. And if it's not there, then it probably is feet and inches. So the fact that they're the same doesn't make things confusing at all. You just need to know what it means. Okay, so we want to convert. Here's how we convert. It says, follow the example below to convert 31.875 degrees to degrees, minutes, seconds form. So we take just the decimal part, this 0.875, because we know that's 31 degrees, and then we'll figure out how many minutes and seconds. So we take 0.875, and by the way, this is the exact same conversion you would do if I said it is 31.875 hours, okay? If it's 31.875 hours, it is not 31 hours and 87.5 minutes. We agree with that, right? You have to do some converting. It's exactly the same. The problem is some of you don't even know how to do that. So 0.875, what do I multiply that by? 60, right? Because this is a part of an hour or a part of a degree. So this is how many minutes are in that degree. So you multiply by 60. And what do you get? Yes, and good question, because this calculator is going to give it to you in fraction, right? We actually want this in decimal form, so you're going to have to hit the little button. 52.5, right? Okay, so now we're not going to say 31 degrees and 52.5 minutes. Now we take that decimal part, which is just that 0.5. So basically it's like half a minute. You multiply that times 60 for the seconds. And what do you get? 30. Because doesn't that just mean like half a minute? It's 30 seconds, right? So this is how you break it up. So what that means here is then that we have 31 degrees, and then this 52 minutes and 30 seconds. They are the same measurement. It's just notated different ways, okay? And now you're using a calculator for this because it makes sense, because it's just not real pretty if you don't for most of this. And I'm going to let you use a calculator, but would you absolutely have to have a calculator to work that problem? No, like you're capable of doing it by hand. You won't enjoy it, but you're capable of it, right? So there's a difference between it being a calculator being nice and a calculator being required. So yes, you have to do some work, and a calculator is not required, but is useful. But you're not going to be able, in most cases, to look at a decimal degree and just know what this is going to be. You're going to have to do the conversion, whether you do it by hand or do it on a calculator. But again, if it was like 31.5 degrees, you could probably come up with that without any work. But in this kind of case, these aren't going to, make a whole lot of sense when you just look at it. Okay, so it's going to take a little bit of work. So the question came up last period after we were done, actually, and it was, so who even uses this? When would you use it? Except for in word problems, obviously, because that's why we're doing it now. Because tomorrow we're going to start looking at how to find missing sides and angles of triangles that aren't right triangles. And I'd taken some of this notation out of some problems we had already done, because I skipped this before Christmas for a specific reason. But I felt like you still need to experience it. Not everything is going to be in this form, but we need it in this form so you know what to do with it. But why we would care about this is how geographically things are measured most of the time, or not most of the time, but latitude and longitude. When you talk about, it's 35 degrees and 52 minutes, north latitude or whatever. So latitude and longitude, so if you're using a GPS, you could see it one of two ways. Your GPS coordinates can come up as decimals, right? They're never pretty decimals, but they can be written as decimals, or they can be written in degrees, minutes, seconds. So if you're an airline pilot, or if you're a ship's captain or something, that you're using the GPS and you're trying to plot routes, most of the time it's written this way. And so you either you understand it this way and know exactly how to do it and it makes sense to you because that's what you do in your career all day long, or you at least know how to convert it. It's also tied kind of to nautical miles. Okay, so nautical miles are different than the miles that we talk about that we drive, in our cars or whatever. So nautical miles is what pilots use, even though it's nautical like in the water, that's still what's used for aircrafts because the earth is round, right? So it's a little bit different than just going on a straight one. Lines of longitude, right? They're all the same circles. Does that make sense to you? But the latitude, you know how they get smaller, up how you get closer and closer? You're talking about lines of longitude, then 1 nautical mile is about 1 minute as far as angles are concerned. And so you know how far you've gone. You can talk about it as a distance, kind of like an arc length. And I say about because it is the circumference of the Earth, and it's 1/60th of a degree is how you would measure that. But the problem is the Earth isn't exactly spherical. It's kind of oblong. So that's kind of an estimate as far as a nautical mile is concerned, but you can tie those two things together. So latitude and longitude in whatever, ways that might be applied in whatever career, or just, again, you seeing it on your GPS or you seeing it somewhere like that. At least you know it exists. I'm not saying you're going to have to convert it every time you see it, but you know what the heck it's even saying, okay? All right, so it says write each angle measure in degrees, minutes, seconds form. Obviously, we are not doing every single one of these. We don't need to. We're just going to do a few. Let's do number 1. We've got 15.48 degrees. So this is going to be, well, I know it's 15 degrees and then something, right? So I'm going to take the 0.48 and I'm going to multiply it by what? 60. And when I do that, what do I get? 28.8. So that tells me then that it's 15 degrees in 28 minutes. Then I take that 0.8 and multiply that by 60, and that gives me 48. So then it's 48 seconds. So that 15.48 degrees is 15 degrees, 28 minutes, 48 seconds. Okay. All right, so then let's do number 2. So I know it's going to be 150 degrees. And I take the 0.2, multiply it by 60. What does that give me? 12. So it's 150 degrees in 12 minutes. And there are no seconds on that answer, and that is absolutely fine. There has to be, right? Everybody okay with all that? All right, so I want you to jump to number 6. Go ahead and mark number 6 on your own. All right, so we get to this, right? And then what do we do? Now, it is acceptable to have decimals in seconds, but we're not going to. We're going to go ahead and round up. So we could say 273 degrees, 46 minutes, and 15.6 seconds. But we don't need, we're not running an Olympic race where we have to be that specific on the seconds right now. It's fine. It's not time anyway, but, we don't have to be that exact. Now, if you were flying somewhere, you were trying to make it to a specific place out in the ocean, you probably want to be a little bit more exact. But you just use whatever rounding rules apply. So this would round up to 16 seconds. So you get 273 degrees, 46 minutes, 16 seconds. We all okay with that? Yes? All right, good deal. So that's getting it into that form. More likely, you're going to have it in that form. You need to get it out of that form because mathematically, we need the decimal because even this nice fancy calculator isn't going to like that. Oh, shoot, I did it again. All right, let me go back here real quick. I want you to think about what's happening with these pieces. So I took this 48 or 0.48 and I multiplied it by 60, right? Then I took part of that result and I multiplied it by 60 again. So some of this decimal got multiplied by 60 twice, yes? So since it got multiplied by 60 twice, what did it really get multiplied by? 3,600, right? So when we go the opposite way and we divide, we're not just going to divide by 60 and divide by 60 because one of the pieces got divided by 60 twice. So I just want to make sure you understand why it's going to look a little bit different. So if I have this in degrees, minutes, second form, I need it in decimal form because that's going to make more sense to me anyway, plus that's something I can actually use to calculate. So yes, it's 73 degrees, and then this 9 minutes, I'm going to divide that by 60 so I can figure out what part of the degree that is. And when you do that, you get 0.15, yes? All right, so then you're going to take those 50 seconds, and I'm not dividing it by 60. The seconds I have to divide by 3,600 because I'm jumping from seconds all the way back to degrees. Okay. And then when you divide that, and I think this is one of the ones, let me see. Yeah, it's a repeating number. So when you get that, first of all, it gives you the fraction. So then you have to hit that button. It gives you the repeating, which you can totally figure out how to round it with what you see on there. But if you hit that SD key again, then it gives you the actual decimal. So if you get a repeating decimal on there, it actually toggles through three options instead of just two, just FYI. So this gives me 0.014, right? So that means that this 73 degrees, 9 minutes and 50 seconds, I would take 73 plus 0.15 plus 0.014, and when I add all that up, that gives me 73.164 degrees. Now, as I was preparing for this lesson, I was thinking about the fact that I say so many times, you are never, ever, ever going to write down a rounded number and type it back in your calculator. Like, never. You're never going to do that. And this is why you never say never, because this is a case where you do that. But when you're doing that, it's still making this correct to 3 decimal places. So this is one of the very rare occasions where we're not keeping it exact and putting it all together, because even if we did, we're going to end up with the same thing in the end anyway. Okay? We good? So let's look at number 10. So it's 315 degrees in 8 minutes. So I'm going to take that 8 minutes and I'm going to divide it by what? 60. So when I do that, 8 divided by 60, I get 0.133, right? You are not going to write 0.13 repeating. And then there are no seconds on here, and again, that's fine. 315.133 degrees. And that's a more usable number for us. Now, number 12, I want you to change that to negative, because there's some negative numbers on the homework, and there's not a single negative example on here, and I've had a lot of questions about that, so I want to work this one. Basically, we're going to work it exactly the same. The safest thing to do, I think, is to just ignore the negative, do what you're going to do, and then stick it back on there in the end. And there's questions about what to do with that, and I understand that. So let's do this one, and then we'll look at that. So I'm going to take this 4 minutes. I'm going to divide it by what? 60. And then I'm going to take the 45 seconds and divide it by 3,600. So let's get those numbers. So this is 0.067. And 0.013. Okay, so the question has become, well, since it's negative, do I add these together? Do I subtract them? Like, what am I really doing here? Well, if you think about what's happening on a number line, I mean, yes, you're going to technically be subtracting them, but you don't have to overthink this. If this is a going in the negative direction, right? The absolute value of the number itself is actually increasing. It's just, but the number itself is getting smaller because it's negative, right? And if you try and really overthink that, you're going to confuse yourself. And so either, yes, it's a negative 121, so then you subtract both of those, that's fine. But it's the same as adding them all up and sticking the sign on in the end. Okay, so don't make it harder than it is or overthink it. It's the same thing. Knowing that, yes, you're technically adding the number, but it's getting more negative, so it's getting smaller. So we're just going to add the 121 plus 0.067 plus 0.013. And so then in the end, since this is negative, we get a negative 121.08 degrees. Everybody okay with that? Any questions? This is pretty easy, right? Okay, so I want you to do number 13. 13 while I hand out the homework, so you can just prove to me that you really, really got this. Then we will be done. But if you have a question, please don't be afraid to ask, especially since I just said it was easy. I don't want you to be like, yeah, 13. That is what you should get on 13, so make sure we agree with it, with each other when you're done. And I want to show you one more little graphic on here. Have any of you had to deal with your GPS coordinates for any reason? Or, I mean, you've seen them on things, right, at some point. And again, they could be as decimals or they could be as degrees, minutes, seconds. But when you talk about your latitude and longitude being 37 degrees north or 47 degrees south or east or west, the reason the hemispheres are put on there like that is to avoid the negatives. So if we're talking about, like, here's what's the zero for the line of longitude? I can't even draw. What's it? Has a name. Prime meridian. Okay, good. So here's my globe. It's not going to be a beautiful one, I know, but I'm going to try. So here's my globe. Here's the equator, and then here's the prime meridian, right? So this is like my zero. So instead of talking about going this way, it's positive, and this way, it's negative, I have this many degrees east and this many degrees west, that sort of thing. Or I can go north and south, things like that. So they use the north and south and east and west instead of saying I'm going in negative whatever when you're talking about latitude and longitude. So that's how that applies to that. So next time you see GPS coordinates, you'll at least know if it's in degrees, minutes, seconds or not. I highly doubt you'll need to convert it right now, but you at least know that you can. And maybe you could wow people at parties. We're like, oh, those are your GPS coordinates? Let me show you this. And then you're like the cool kid. So, all right, go ahead and glue or tape this in.